Let us take another example of a bar element, and we are going to solve this using the Galerkin method. So in this problem we have a fixed free bar, fixed at A, free at B, and subjected to a point force P at the free end. Here we have to determine the displacement using the Galerkin method. The details of the bar are given in the diagram. We know that the governing equation of a bar subjected to a concentrated load P at the free end is given by EA dou square U by dou x square plus Q naught equals to 0. Now applying the boundary conditions, we know that at the fixed end at x equals to 0, the displacement is 0. In the derivations that I had shared with you all before, there were two essential boundary conditions, right? So the first boundary condition was EA dou U at L upon dou x minus P equals to 0, and the second boundary condition was EA dou U by dou x equals to 0. Okay, so this boundary condition we used in the previous problem where we had a bar element subjected to uniform axial load throughout its length. Okay, so this is the essential boundary condition we used in this case. In this problem, in problem 2, we are going to use this essential boundary condition. So we have at x equal to L, equals to P. Let us assume a approximation function in polynomial a0 plus a1x plus a2x square. You know that a0, a1, a2 are constants which we have to determine. Now applying the first boundary condition, we will get a0 equals to 0. Let this equation be 1. Let us differentiate equation 1 with respect to x and apply the boundary condition 2. Okay, so this is the first boundary condition, this is the second boundary condition. When we do this, we'll get a1 equals to P upon ae minus 2l a2. Substituting the value of a1, we get this equation. Let us now label this as equation 2. Okay, so let us consider the general displacement solution for the Galerkin method, like phi 0 plus phi 1x, it's a1 phi 1 plus a2 phi 2 and so on. Now comparing these two equations, if you see, there is no there is a constant term here, okay, that is this equation here. So your a0 will be equal to px upon ae, or sorry, this is phi 0, not a0, this is phi 0. So phi 1, there is no a1 term here to compare it with. There is no a1 term. So phi 1 will be 0, and phi 2 will have the coefficient of A2 in equation 2. So phi 2 will be equal to x square minus 2lx. So if we have to write this equation in terms of phi, it will be only phi 0 plus A2 phi 2, since there is no phi 1 term in this equation of displacement. Next, we have to use a weight function. So let us take only one weight function in this case, okay, and try it out. So let it be W2. So W2 will be equal to phi 2, which is x square minus 2lx. Okay, there is no phi 1 term here. Had there been a phi 1 term, then we would have been taking W1 and W2. And the residual, which is Rd, we know is given by Ea dou square u by dou x square plus q naught. Now substituting this equation and simplifying it, we will get Ea for dou square u term is px upon Ea, that is the equation 2. On differentiating it, we get this. So for the minimum residual, what we have to do is 0 to L W2 Rd dx equals to 0. Substitute for W2 and Rd. Once we integrate this and apply the limits, we will get A2 as minus q naught upon 2 Ea. So we've got the value of A2. We have to now substitute the value in equation 2. So this is the displacement at position x when the bar is subjected to a uniformly distributed load q naught and concentrated load p. Okay, now in the current case, we know that there is no q naught here. So when we substitute for q naught equals to 0, we will get this equation. So this is the equation that we require to get the displacement at any point when it is subjected to a point force at the free end. Now if we want to get the displacement at the point B, we know that x equals to L. So the displacement at L, or at the point of application of say P, we will get PL upon AE. Now what I want you to do is solve the same problem, okay, using this q naught as 0 in the very beginning. Okay, now here we solve the entire problem and we have in the final step put q equals to 0. So I want you all to try out what happens if this q naught is put as 0 in the very beginning. Thank you.